Another conic section we want to explore and try to understand a little bit about is hyperbola. Now, a hyperbola is the shape that's formed when I have two foci and the difference and their distance to a point on the line. For example, from here to there, the absolute difference or the absolute distance of the larger one take away from the smaller one is constant all the way around. So this distance minus this distance would equal maybe that distance minus that distance, or that distance minus that distance. All those distances remain constant. So all the points where that's true represents a hyperbola. And a hyperbola looks awfully similar to what are those? To ellipses, other than one, maybe two little differences. The first major difference is the subtraction sign rather than the addition sign. And then also to how we identify what our a squareds and b squareds are. A squareds in this particular case are the number or represents the number that's part of the term that precedes a positive sign. So my a would go here because this term is positive. And this one, my a, would go underneath my y because my y is positive. So I have two examples up here. And first of all, we need to identify what kind of a conic section is this. Is it a circle? Is it a parabola? Is it an ellipse? Or is it a hyperbola? And it looks like an hyperbola. And looks like we have two different types. I noticed that I have an x squared minus the y squared. I have the y squared minus the x squared. So let's begin with both. Well, let's begin with the one on the right. Well, let's begin with the one on the left to figure out what we know and how to graph that. So first of all, I need to know what my A and my C's are. Those are the significant points on that we need to discover. So A squared equals 16. So A equals 4. So now I know where my vertices are at. I also know the difference between these two, that the transverse axis is the one that we call so the parabola works around the horizontal transverse axis when I have a positive on my x squared term. Likewise, or not likewise, but alternatively, when my y squared term is positive, which has that first positive term, my transverse axis is the vertical axis. All right, so on this first example, a equals 4. Now I need to figure out what my foci is at. Foci is determined by c squared equals a squared plus b squared. That's going to equal a 16 plus a 9, which equals a 25. So c equals 5. All right, so there we found all of our significant points, and we can begin to draw the graph. I'm going to try to draw a little small in here. I have vertices at 4 and 0, so I probably should put my tick marks on it for you. One, 2, 0, 4. 4. One more tick mark beyond that. So that's where my vertices are at. My foci are at 0 and 5, or 5 and 0. And from there, we can begin to get the shape of the hyperbola. Notice that my transverse axis is the x-axis. I have vertices at 4 and 0 and negative 4 and 0. And then I have foci at 5 and 0 and negative 5 and 0. All right, you guys feeling all right about that? All right, let's begin with look at this third one, or this next one over here. Y squared over 9 minus x squared over 16. My a squared in this case is 9. So a equals 3. And then my c squared is again a squared plus b squared, so c in this case is a 5. Same 5. So to graph that, my transverse axis is the vertical axis because my y squared is my positive term. I have a's up to 3. Oh, 3, 1, 2, 3, sorry, and down 3. I have a foci up at 5s and negative 5. And from there, we can get a rough sketch of what that hyperbola looks like. All right, so that's a little bit of an introduction to the next conic that we're looking at, a hyperbola in standard form, and the general shapes of what these hyperbola graphs look like. Trying to work this one backwards, we're given some initial information. It says our foci are at 0 and negative 3, and 0 and 3, and then we have vertices at 0 and negative 2, 0 and 2. So we must ask ourselves, which kind of a hyperbola is that? Is that one where we have a horizontal transverse axis or a vertical transverse axis? Well, notice our vertices, where their locations are at. The vertices are located on the vertical axis. So I know then that I have vertices at 0 and negative 2. And 0 and positive 2. So those are my vertices at. I know I have a vertical transverse axis. And then I have foci located at 0 and 3 and 0 and negative 3. All right, so now I have a little bit of information to know which of the standard forms I will use. Since it's a transverse axis on the vertical side, my standard form is y squared over a squared minus x squared over b squared equals 1. And from there, let's just do a little bit of work. We know what our a is. Our a is a value right there at 2, so a equals 2. Or a squared equals 4. The b we don't know. The c we are given. The c is a 3. So c squared equals 9. I know that c squared, where should I do it? Let's do it down here. C squared equals a squared plus b squared. C squared is a 9. So 9 equals a squared, which is a 4, plus b squared. B squared looks like it has to equal a 5. And now we have the remaining information we needed to write the hyperbola in standard form with a transverse axis along the y-axis, and that becomes y squared all over my a squared, which is a 4, minus x squared over my b squared, which is a 5, equals 1. And then the graph, just because we like to draw pretty pictures, looks like such as that. So there we have a hyperbola written in standard form.